You may be familiar with the old saying, oil and water don't mix. When placed into the same container, oil and water separate into two layers with a boundary between them. Because water and oil don't mix, we say that these two liquids are immiscible. The water and oil molecules are prevented from mingling together because the intermolecular forces, or attractions between their molecules, are very different. Water molecules are polar in nature and are held together by relatively strong forces called hydrogen bonds. On the other hand, oils are nonpolar molecules and are held together by relatively weak forces called van der Waals forces. Whether two liquids will mix or not basically comes down to the concept of like molecules mix with like molecules. But, as we have just seen, water and oil molecules are not alike. However, it is desirable for water and oil not only to mix, but to stay together in a number of food products, such as milk, mayonnaise, salad dressing, butter and margarine, baked products, whipped cream, chocolate, peanut butter, sausage, cheese, and ice cream, just to name a few. The good news is that there are molecules called emulsifiers or surfactants that can be used to hold the water and oil molecules together in a system called an emulsion. Emulsifiers are amphiphilic molecules. That is, they are composed of two parts, a hydrophilic part that likes to interact with water and a hydrophobic part that likes to interact with oil. There are two main types of emulsions, an oil in water emulsion and a water in oil emulsion. In an oil in water emulsion, the hydrophobic part of the emulsifier interacts with the oil droplet, and the hydrophilic part of the emulsifier interacts with the water. Several emulsifier molecules are used to stabilize each oil droplet, which is dispersed in the continuous water phase. Examples of oil and water emulsions are milk, mayonnaise, and salad dressing. In a water and oil emulsion, the hydrophobic part of the emulsifier still interacts with the oil, and the hydrophilic part of the emulsifier still interacts with the water. However, the dispersed and continuous phases are reversed. The oil is now the continuous phase, and the water is now the dispersed phase. As before, several emulsifier molecules are needed to stabilize each water droplet, which is dispersed in the continuous oil phase. Examples of water and oil emulsions are butter and margarine. Emulsifier molecules stabilize both oil and water and oil emulsions. These emulsifier molecules can be thought of as anchors that keep the dispersed phase from separating out of the continuous phase. But where do these emulsifiers come from that stabilize these products? Some emulsifiers are found naturally in foods, such as in milk, whereas other emulsifiers need to be added to foods, such as in salad dressings. In the case of milk, naturally present proteins and phospholipids in the milk emulsify the fat globules and prevent them from separating from the continuous water phase. In the case of salad dressings, as well as many other food products, emulsifiers are added to stabilize the water and oil interaction. There are a number of emulsifiers that can be added to create stable food products. All of the emulsifier molecules have one common feature. They are composed of two parts, a hydrophilic part and a hydrophobic part, such as the monoglyceride emulsifier molecule shown here. The hydrophilic portion of the monoglyceride molecule interacts with the water phase, while the hydrophobic portion interacts with the oil phase. Other types of some emulsifiers include diglycerides, phospholipids, such as lecithin, which can be found in eggs and soy, fatty acid esters, and a variety of protein molecules. Water and oil don't mix on their own, but with the help of emulsifier molecules and some mechanical work, water and oil can be persuaded to stay together, producing many of the food products that we consume every day.